So, good morning everyone. Today we are going to have a lecture on statistical quality control. So, why it is required, basically statistics is generally utilized in any kind of an industry in order to minimize the whole concept. So now this statistic quality control means basically we are going to apply this thing on the quality part. That means we are going to minimize the concept or minimize the time frame of the process, and we are going to generate more production. So obviously, controlling is being done in a chemical industry by two ways. One is the process control, the other one is the product control. So now today we are going to look into the product side part. So that's why the lecture I have defined today is statistical quality control, detailing about the whole chemical process. So I myself, Dr. Saurabh Poddar, I am going to present the whole lecture on statistical quality control. So as you see from the initial presentation of it, you see that I have started with a flow sheet. So what does this means? Obviously, when we are going to do the whole system or whole concept of utilizing it, we will have a flow sheet that will have a start followed by the product goods. Then after the goods that we are going to have it down, we are going to take samples out of it, and then we are going to create some kind of charts. That means we are going to provide some kind of quality controlling parameters out of it, and we are going to inspect the whole sample that is being required for the company to produce. So now in that case, if we or when we are doing the quality control, we observe that a whole process has a rejection. Then we are going to reject the whole process from the sample. If it suggests that it requires a rejection, therefore the whole rejection will go by. Now if one part of the sample suggests that it doesn't require any kind of a rejection, then we are going to select the whole sample. So now, before starting into the whole part, we need to know certain definitions related to it. So what it is quality control. So or you can say statistical quality control is basically the checking of the quality that we are going to implement. So obviously from the slide you can understand that quality of a product is satisfactory when it is able to satisfy the stated and implemented needs of the customer. So in that case, we need to do certain parameter check, and we will try to observe how we are going to obtain the whole process out of it. So basically from the definition we understand the two important things. We are going to optimize or we are going to check the parameters that are required to obtain the finished product, and finally requirement needs for the customer. So suppose I generate some kind of ABC kind of a product which the customers are not liking it, but EDA products the customer are liking it. So obviously I will not go for the production of ABC. So that is the main thing we will try to utilize this software and other parameters or other concepts to generate the whole part so that we can fulfill the needs of the customer. So obviously when you go to a chemical industry, they generally try to do this thing and we try to maximize the profit out of it. So now as it is being written in the initial slide, I mean the top part of the slide, that statistical quality control is a quality. So obviously it will come to your mind what is quality is meaning. So quality means it is has to be a plan, achieved, controlled or improved continuously. That means we are going to obtain the whole thing that I have said earlier. So all these things are required from time to time in order to satisfy the needs of the customer. So now we said that a quality is needed, and that quality will be requirement for the customers, and also it has to be checked by the industry. So obviously this quality checking, as I said, softwares and then other parts I said so. So two parameters are generally followed. One is the quality of the design, the other one is the quality of the conformance. So obviously design means obviously certain parameters are there. We will set certain parameters as a fixed parameter, certain as a variable parameters. So this fixed parameters you call it to be the dependent parameters, and independent parameters we call it to be the indirect or anything else. So design wise we will try to obtain the whole part of it, and we will try to minimize the state, because if we do it experimentally it will take a tedious amount of time which is not required, or we cannot able to reach the goal that we want to reach in a short period of time. So obvious definition for the quality of design, it is basically referring to the differences in the specification of the products which have same use. So you see, it, we are placed at Haldia. So obviously, when we are having a fever, we go to a medical shop and we say that we require a paracetamol, and obviously the chemist provides with a paracetamol named as Yocalpol, and it has various dose forms, so we will not go details into it. So now if you are in the southern part of India, you will observe this paracetamol is being defined with a different company name, that is Dolo 650. So Dolo is the company name. So over here it is Calpol, and over there it's Dolo. So this way the quality remaining the same, but design wise, parameter wise, and place wise the things have got changed. So they try to make rectangular shape of a tablet, and over here we generally get a spherical kind of a tablet. So all these parameters comes under the quality of the design. They work similarly, but we have to check all these things. So in case of, this was an example for your pharma industry. Now you go for your chemical industry. So one example is given. Different brands of razor blades may differ in specification with respect to steel use. So obviously steel has various grades. So various companies provide various grades of steel into the razors, so that they can define it as a different suitable product that can be utilized. So quality of design is therefore can be said to be the method of the construction, processing, material use, style factors, and also the safety factors that is important. So each definition wise, obviously it can create a large lecture. So I just try to just compact the whole thing, and I try to generate a simplified results for you students, so that we can get a basic idea what it means to us. So quality of design basically means the difference in the specification we are going to make, and we are going to generate a final product out of it. The next one is the quality of conformance. So obviously I have highlighted ability of production process to maintain specified quality of design in the long run. So that means obviously I generated a product which is not having a proper utility. So obviously I will not be in a state to sustain. So this parameter will also be checked using this theory that we have going to implement, that is known as the statistical quality control. So over there we are going to apply this quality of conformance for generation of our stability of the product. So while doing so, we need to go for certain parameter check. That is, we need to have certain techniques. So these techniques will be managing of the parameters like your monitor that is being used, then the temperature, pressure, and controlling of these things. So all these things will coming under the, and then the diagnostic of the whole system. So and the standards that we are using. So obviously when we go in any kind of an industry, they have certain standards. These standards are not generally linked. So obviously they follow a certain standards, international standard obviously, for production of their product, and marketability of the product also they use standard. So this all things comes under the quality of conformance. So after going detailing of this quality of your design and quality of conformance, we will now go into the main objective of the subject. So, what is the main objective? Why a company, any kind of a company, will try to utilize this statistical quality control? Even in your IT company, your chemical company, your you can say your steel manufacturing company, your bakery company, why they generally does this statistical quality control? Because all companies want profit. So when they want profit, so obviously they will have to minimize the production. So and in order to generate the profit, so the basic and the first important point is the company's income for manufacturing cost has to be reduced. So they will reduce the cost in order to generate a proper or improved product. Also, they will also reduce it. So this is the main objective. Companies' income by manufacturing products on a large scale has to be maintained. The second one I talked on a largely, that is the reduce of the company's cost. So this is most important parameter because most of the companies will want reduction in the cost and maximization of the production. The next one, while doing these two parameters, that is profit maximization, reduction in company's cost. So obviously we are trying to apply the steps that are involved in the statistical quality control is the optimum quality of at a minimal cost. So this is the important parameter another, and then the last, when they generate the product, last not the least, I said so because there are other points also. So that is the satisfaction of the customer. I generate a product which is not satisfying the customer is not going to help. So the next objective has to be satisfaction of the customer is a very important parameter we need to look. The next one is the standards and taking suitable action immediately has to be maintained and developing the quality and performance of the machine. So when we do any kind of a techno-economic assessment, we generally take 20 years the lifespan of the plant or process, and then we go for decommissioning. So obviously the performance of the machine is also an important parameter that has to be taken into the quality control that comes under the process control. So we are not going in details into it, we are going into the product part. So but it is an important parameter that has to be taken into account while generating the final product. So now after the objectives, the characteristics that has to be maintained. So what are the characteristics? Technical parameters has to be checked. That is the hardness, then your diameter, strength, lifetime, etc. We need to check from time to time. Then the physiological factors that are involved in the quality like beauty, odor, color, taste. So all these parameters has to be checked. Next one is the ethical parameter. So what it is, how honestly we are making. So obviously we see most of the companies or most of the manufacturers, they do some kind of honesty, and if they got, they generally go for court cases and all those things. So this corruption and all those things is not an important part. You got an example that once Maggie was having some iron component into it, so this production rate got decreased because consumers started disliking the product. So there was a dishonest. So when you have a honesty in your production, so obviously your production will increase and the profit will also increase. And the last, that is the contractual parameter. So what it is? Guarantee. How guarantee, safety, provision parameters we are going to provide down to the customers. If we don't provide anything satisfaction to the customers, so they will not be in a state to understand what we are trying to generate or we are trying to produce. So while doing so, so we will be applying two variables. So one is your direct measurable, the other one is your non direct, you can say so. So I try to define it as your directly measurable, that is the variable. The next one is non-measurable. So what comes under thickness, directly we can measure down with the help of scale. Then your life length, we can see down temperature, tensile states, then your production data continuously. So all these things we can see down, but we cannot measure Suddenly we are working with a process and suddenly get cracks. So we need to work it with the cracks, breakages. This parameters we generally is not present. It happens at a instant of time, and that time we need to take measures, but we also need to remember this thing. So this is a part of the thing we need to put into it, and we need to calculate the whole parameters out of it. So we'll try to see whether we are in a state to do so or not. So what causes the this was the technical. Then after the technical we had the quality characteristics, and then finally causes the variation. So first one is your design of the quantity, next one is your problem of conformance, then your variability that is being linked to it, and then the variation of the quantity of manufacture. Now a new terminology is coming, variation. So all the terminology are known, but each terminology has a specific significance which you need to remember. So why variation? Because we in the last slide we see there was a breaks, cracks, stresses, vibrations. So these variations were not taken into account while we talked about the product. But now when we are generating the product, and then when we are going for the packaging of the product, so these variations might come down from time to time. So this variation parameters has to be taken into account, and we have to walk it down it with this. So with this we go into the next slide, that is the what affects the variation. We said that there might be variation, so these variations can be affecting it down. So what might be? So the first one is the chance causes, the next one is the assignable causes. So chance causes means a crack might happen at a certain place. We take it a point, but we are not known that what point it will be happening. It can happen in the first day, it can happen after 20 days. So all these parameters comes under the chance causes, minor causes, then variation due to causes is beyond the control of the human. All these things comes under the chance causes. The next one is the assignable causes. So what is assignable causes? It is being defined on a largely, that is the non-randomable causes or special causes. Like suppose when the temperature rose up to say 42 degree, the reactor started behaving unequally, or the product formation parameters, or I mean to say the properties of the product formation was not same. So this parameter changed. So all these properties are comes under the assignable causes, because it is happening randomly. At the certain day, the temperature rose, the product parameters change, and we got a product that cannot be delivered to the customer. But if we recycle the product and we started utilizing the product, we can utilize or generate a betterment of the product we can do so. So these parameters comes under the assignable, and the first one was the chances like cracks, then your pipe getting broken down, labor not coming on a certain day. So all these parameters are your chance causes. Assignable causes, I said so, can be detected, can be eliminated. So on a large scale, we can say so, natural or inherent or a allowable variation plus unnatural gives us the total variation of the production process. So this is the important part we need to know, unnatural and natural. So with this we move down into the next one. The main purpose is the separation of, I mean to say, statistical quality control is separating the chance causes and assignable causes, and then combining it down and then generating the outcome of it. So process variables can be in a pattern like the graph is showing that one is having a hump, then a ramp, followed by this whole thing. So all these parameters we need to combine, and we need to bring a final output that will be in a proper curve shape, so that all these parameters might not affect the process out of it. So with this we stop our current class. We will go more details of these parameters, and we will try to generate a more outcome of it. Thank you everyone. We will see you in the next class.